Hi everyone, welcome to this video. So in this video, I will explain all the question in the after class section. So let's start with the teaching time. So answer the following questions. Circle any shapes below which have only one line of symmetry. Okay, so be careful. We need the one that is only one line of symmetry. Only. So the triangle. The equilateral triangle is not the shape that only have one line of symmetry because it has three, right? So 1, 2, 3. So that's why this is not the answers. There are 3 lines of symmetry already. And then a rectangle is not the answers as well because there are 2 lines of symmetry, the vertical lines of symmetry and the horizontal lines of symmetry. Okay, so that's not true. A regular pentagon is obviously not true because a pentagon is a 5-sided regular shape. There must be 5 lines of symmetry. So these are the 5 lines of symmetry. So that's also not true. So the arrow is actually the answer because arrow only have 1 lines of symmetry, the horizontal lines of symmetry. So that's why the answer is the arrow. Arrow is the only answer. Now, let's do the second one. Draw all the lines of symmetry of the shape below. Okay, so for this star-like shape, there are actually 4. So the vertical and the horizontal, and then you can also have 2 diagonals one. So these 4 are the lines of symmetries. Okay, lines of symmetry. Now we go on to question 3. Reflect the shape in the dashed line. So when you reflect the shape, you just have to measure the perpendicular distance between corners to the mirror line. So this is the mirror line, right? This is the mirror line. Okay, so if this is the mirror line, you have to measure the perpendicular distance between corners to the mirror line. So this is the corners, and if you draw a perpendicular distance, a distance to the mirror line, that's 90 degrees. Okay, then you can see this is actually 2 layers away, right? So on the other side of the mirror, the corner should also be 2 layers away. Okay, so now we can line this up. Then we get the reflected shape. Okay, so that's basically the answer. Now we go on to question 1, the homework. How many lines of symmetry does the shape on the right have? There are 6. Okay, so we have these one. By connecting the gaps, we have 3. And then by connecting the corners, we have another 3. So 3 plus 3 equals 6. Okay, so that's why the answer is 6 for question 1. Quite easy. Now we go on to question 2. In the figure below, how many squares you should shade at least, okay, at least, so that the figure is symmetrical. Okay, so the question gives you the mirror line already. You have to make it symmetrical across these diagonal lines. Okay, so now you have to think about each shaded region will actually reflect it to which square on the other side of the mirror line. Since you want to find out the minimum amount that you have to shade, you just have to reflect those that are shaded. You don't have to create other symmetry, right? So first, the square 1 after reflection will go right here because you have to reflect it in this way, right? So this is the 1. This second one is already right here, so you don't have to shade it. And then this one is right in the mirror line, so you don't really have to shade it. And then this one, you have to shade this one. Okay, so that's why how many do you have to shade? It's actually only this and this. So that's why the answer is 2. You have to shade 2 squares. Okay, maybe I change my drawing a little bit. Don't use 1, 2, 3, 4. It may be a bit confusing. So this is A. Then you also need to shade this A. B is already on top of the mirror line, so you don't have to shade anything. C and C, they are all shaded. D, you have to shade this one. So that's why you have to shade the D and the A. So the answer is 2. Now we go on to question 3. Which image complete the symmetric figure using the dotted lines of symmetry? Okay, so now if you want to reflect this shape, you have to find out the perpendicular distance between the corners and the mirror line. So here is the mirror line. We need to find out the perpendicular distance between corners. So let's start with these corners. It is one diagonal away from the mirror line, so the image corners will also be one diagonal away from the mirror line. So this is 1.5 diagonal away from the mirror line. So on the other side, it's also 1.5 away from the mirror line. This is one diagonal away from the mirror line. So the other side is one diagonal away from the mirror line. Okay, this is 1.5 away from the mirror line. This is 1.5 diagonals away from the mirror line. This is half diagonal away from the mirror line. So the image is also half diagonal away from the mirror line. Okay, now we just have to connect the dot. So how should we connect it? Is something like that. Okay, so that's basically the answers. So let's see which diagram looks the same as my drawing. I think it's A. So that's why the answer is A. Perfect. Now we go on to question 4. What is the order of rotational symmetry of this star shape? The order is 5 because the order is asking how many times it repeats itself in a whole turn, right? So imagine you hold these corners, you rotate it here, it will repeat itself. And then here, twice. And then the third time, the fourth time. And then if you go back to where it starts, it will be the fifth time. So that's why there are 5 rotational order. Okay, and then we go on to question 5. Which of the following shape have rotational symmetry but no lines of symmetry? Okay, so since A has lines of symmetry, so A is not the answer. Okay, we have to find out those that have no lines of symmetry and also have rotational symmetry. So A is wrong. B don't really have lines of symmetry and it has rotational symmetry, right? Because you can rotate it right here, right? So you can see it has rotational symmetry. So B is one of the answer. And then C. C is also one of the answers because there are no lines of symmetry and you have rotational symmetry. D has rotational symmetry, however, they also have lines of symmetry, right? So that's why D is not the answer. So the answer is B and C.